Welcome to the Explainer. Today, we're taking math off the chalkboard and dropping it right into the high-stakes reality of running a company. We're going to shift abstract algebra into practical reality by exploring how systems of linear equations are the exact tools businesses use to calculate profit, loss, and ultimately survival. If you've ever wondered how a company knows the precise moment they finally start making money, well, you're in exactly the right place.
Here's our quick roadmap for today. We'll start with the break-even question, then move into the substitution method and the addition method. After that, we'll categorize things into 3 types of systems, and finally, wrap it all up by investigating business profits.
Okay, let's jump right into part 1, the break-even question.
To really get why this math matters, let's step onto the factory floor. Imagine a bicycle manufacturer. They're pouring money into rent, materials, and salaries, all while simultaneously bringing cash in from bike sales. To survive, they have to answer one absolutely critical question. How do they know the exact moment they stop losing money and finally turn a profit? A simple guess just isn't going to cut it here. We need a precise tool.
And that brings us to that tool, a system of linear equations. This is simply when we look at 2 or more linear equations made up of multiple variables at the exact same time. The ultimate goal? Finding that one perfect numerical sweet spot that satisfies everything at once, that single point of intersection.
Which leads us to part 2, the substitution method.
Now, graphing these equations is great, but real-world solutions often involve some pretty messy decimals, which makes graphs a bit imprecise. That's exactly when we turn to the substitution method. It's incredibly practical because it lets us focus on solving for just one variable at a time using a super straightforward 4-step process. First, you solve one equation for one variable. Second, you take that expression and literally substitute it into the second equation. Third, solve for the remaining variable, and finally always verify your solution by plugging it back in. It's just a really elegant way to bypass the limitations of graphing.
But what if that doesn't work perfectly? That brings us to part 3, the addition method.
Because let's be real, what if substituting creates a chaotic mess of fractions right out of the gate? That's where we actively manipulate the equations using the addition or elimination method. Check out how multiplying the top equation by 5 and the bottom by 2 changes things. By doing this, we're purposely making the x coefficients match, but with opposite signs, so a positive 10x and a negative 10x. When we add the 2 equations together, that variable literally vanishes. The sum is 0. From there, finding the remaining variable is an absolute breeze, and we just plug it back in to find the other one. So what happens if our business scenario levels up to 3 variables and 3 equations? Well, the exact same logic easily scales up. We can use the addition method repeatedly to first eliminate the variable c across multiple equations. That boils our complex 3x3 system down into a much simpler 2x2 system. Once we find A, the dominoes fall, and we quickly find B and C. It's just a remarkably powerful, systematic way to untangle complex relationships.
All right, moving right along to part 4, 3 types of systems.
As we process these equations, you'll quickly discover they don't all behave the exact same way. The math is actually telling us a story about the relationship between our variables. The first bucket a system can fall into is an independent system. This is usually what we're hoping for. It's a consistent system with exactly one specific coordinate pair as the solution. If you graphed it, you'd see 2 lines with different slopes crossing at one single, highly precise intersection point.
Then we have the second bucket, the inconsistent system. Imagine doing all that math with substitution or addition, and suddenly your equation boils down to a totally bizarre false statement like 12 equals 0. That's just the math's way of telling you there's absolutely no solution. Visually, these are parallel lines. They have the same slope but start at different points on the y-axis, meaning they are never, ever going to intersect.
And our third bucket is the dependent system. In this scenario, your mathematical steps result in an identity, like 0 equals 0. Now, this is a true statement, and it reveals that the equations actually represent the exact same coincident line. Because the lines are literally sitting right on top of each other, every single point on the line satisfies the system. You end up with infinitely many solutions.
So just to quickly recap our 3 distinct mathematical outcomes, you either have an independent system with one intersecting solution, an inconsistent system with 0 solutions because the lines are parallel, or a dependent system with infinite solutions because the lines are coincident. Recognizing these 3 types early on stops you from endlessly trying to solve a system that simply doesn't have a single answer.
Finally, let's bring it all home with Part 5, Investigating Business Profits.
Now that we've got a really solid grip on our mathematical tools and the types of systems we might run into, let's close the loop. Let's apply this power back to our bicycle manufacturing business to see exactly how it dictates financial survival. To find our solution, we have to weigh two fiercely competing forces. On one side, we've got the revenue function. This is the cash flowing into the business, calculated by the quantity of bikes sold multiplied by their price. On the other side, we have the cost function, the cash bleeding out, covering fixed costs like rent and variable costs like materials and utilities.
When we plot all of this out, the big reveal is that crucial point right in the middle. We've got our line representing revenue and our line for cost. That single point of intersection is calculated using our linear equations. This is an independent system solution at the coordinates 7, 33. But remember, in the context of our business, those aren't just random numbers on a grid. Because the x-axis represents hundreds of units and the y-axis represents hundreds of dollars, this point tells us that when the business produces exactly 700 units, the cost and the revenue are identical at $3,300.
This right here is the legendary break-even point. At this precise intersection of 700 units, the company neither makes nor loses a single penny. But look closely at what happens next. If they produce anything less than 700 units, that whole area to the left, they're operating at a loss because the cost line is higher than the revenue line. But shift just to the right of that coordinate and the business plunges directly into that glorious shaded region. Profit. The revenue line finally overtakes the cost.
So, as we wrap up this explainer, I want to leave you with this thought. Math isn't just for textbooks. It's the fundamental language for finding clarity where competing forces collide. We just saw how a business leverages systems of equations to find their exact break-even point. But what about you? What other intersecting factors in your own life, career, or business might be unlocked and solved if you just laid them out as a simple system of equations? Definitely something to think about. Thanks for hanging out with me for this explainer, and keep looking for those points of intersection.